All right, everybody, here we are. This is our final installment of Industry Hour put on by the School of Engineering Hub here at RPI. This is our last installment talking about ECSE programs. I apologize, I am not on an important call right now other than with all of you. I'm having massive technical issues and I'm literally holding my phone to my ear so I can call in and participate in the way that I should be. So apologies for that. Also, I wanted to make sure everybody knows that we are recording the session. So this is going to be available both on our School of Engineering Advisement Hub site, and we also will post that in various places as well. I want to be respectful of everybody's time, so I'll kind of like get us rolling. I have a few screens to share that talks about the CCPD, or the Career Services Office at RPI, and then we'll get started with some Q&A with all of the people that have volunteered to come here today. Before I get rolling on CCPD, I will just go through and have everybody briefly introduce themselves, starting with Saeed.
All right, my name is Saeed Sagatul-Islami. I'm RPI graduate of class of 1974 from the Electrical Engineering Department. I stayed another year and I got my master's degree. Over the last 50 years, I have worked for Bendix Corporation as an engineer on the space shuttle. I've worked for a startup back in the 70s when you became thousandaires, not millionaire. And then I spent 30 years at Bell Labs, AT&T, Lucent, and Avaya, and I retired in 2013 after 31 years. And since then, I've been doing, I've been president of a startup, and I've been chairman of a different startup, and I've done a whole bunch of private equity consulting. And I'm also treasurer of RPI Alumni Association. And I'm running the RPI Princeton hockey game for the Rensselaer Club of New Jersey. We sold out in 2 weeks. We have 140 people coming. And also I'm running the entrepreneurship event in Boston, which is going to be next week on the 10th. And that's going to be available online for you to go look. I guess that should be enough in the way of introduction.
Everyone, my name's Alyssa. Oh, sorry.
Nope, that's a me problem. Go ahead, Alyssa, sorry.
My name's Alyssa Partridge. I'm a graduate of RPI in 2017. I got a dual degree in EE and CSE. I currently work at BAE Systems, and that's where I started working right after I graduated college from RPI. And then while I was working there, I got my master's degree in electrical engineering online from WPI. And I'm currently located in the Southern New Hampshire area.
Thank you. Let's see, Aiden, you're up.
Sounds good. Hello, everyone. My name is Aiden Chen, and I graduated from RPI 2021 during COVID. And currently, I'm working for Viasat. It's a internet service provider for commercial airlines, all the big commercial airlines in the US and also in APAC region. And I am mostly the system test engineer for that company currently, responsible of bringing up different satellite networks in different geographical region for different air business. I work at San Diego, California, work from home as well. And I'm currently completing my master's degree online at the Arizona State University and looking to graduate in 10 days from now. So, yeah.
Congrats. Oh, that's exciting.
Yeah, I was like, oh, perfect timing. And also
that
yesterday was my birthday as well. Yeah.
Oh, happy birthday. Thanks for joining.
Yeah. I was like, oh, perfect timing. Yeah.
Last but not least, we have James, who is a current student here at RPI.
Yeah, so my name is James, and I am currently a senior here at RPI. I graduate technically the end of this month with my bachelor's degree, but I'm going to be staying on an extra year to do the co-terminal master's. So I'll still be in the Troy area for another year.
Amazing. Thank you all for joining us so much. Right now, I'm going to share my screen to show you some slides about the CCPD. because that's an integral part of you working with alumni and current students and figuring out what's going to be out there for you in the field as you talk to your faculty advisor. So here we are. Can everybody see okay? Just a thumbs up. It's okay. Things have been a little off, so I wanted to check. Agenda for tonight, a little CCPD information coming at you. Primarily students that are going to be viewing this video are undeclared engineers or engineers who think that they want to change their major. So the CCPD is a great touchstone for telling you what you're going to do in industry, and that's why we have these experts here with us today. We did the introduction, and then we will have the formal interview by these panelists by the School of Engineering Hub. I'm here, I'm Jen Yeager. Totally forgot to introduce myself with my technical issues. I advise students that are in electrical engineering and computer and systems engineering. And my colleague in the School of Engineering Hub, Kelly Stutz, has agreed to be here. She's helping out with the Q&A, so she'll be monitoring for any questions that might come through. So there is that. And we talked a little bit about the CCPD. This is our point contact in the Career Services Office at RPI. This is Kristen Kettering. She is devoted to helping the engineers here at RPI, and she's able to be accessed through her email address here. CCPD has tons of resources that are available. One of the big things that students will hear about, especially as you go into next year, which will be your sophomore year, is Handshake. That's how you're going to find your full-time jobs and internships and co-ops. And the CCPD office, including Kristen, are there to help you navigate that. They have drop-in hours every Monday through Friday from 1 to 3 p.m. So you can always use that option if you don't go ahead and make the appointment. Something that we're going to spend a lot of time talking about today with our panel of engineers is where people are doing their internships, where they're getting their full-time jobs. So this is a very brief sampling of where electrical engineers and computer and systems engineers are going after they graduate from RPI or while they're doing internships. So that's like a brief overview of that part of the CCPD. We have some really cool salary statistics that come directly from CCPD data. And you can see both electrical engineering and computer and systems engineering have really good hiring rates, really good salary ranges. So we like to make sure that that's all in place. And it is a range, and it's a really impressive one out of the entire School of Engineering, if I do say so myself. Pretty cool stuff for all your hard work. Now, we had the panelists introduce themselves today, and we're going to go ahead and I'll stop sharing my screen so we can concentrate on what we're here for, which is the Q&A with our panelists in the field. So we'll kind of go in the same order as we go through, keep things simple. We'll kind of go on a rotation from Saeed to Alyssa to Aiden to James, and then back around and back around. So the first question is, what made you decide to be a computer and systems or electrical engineer? And I'll start with Saeed there.
All right. Back in my time, when I was a teenager, I was an electronics hobbyist. I used to, build amplifiers and power supplies and radio transmitters and whatnot. Back in those days, it was vacuum tubes. It wasn't transistors yet. So it was kind of like at the time of the dinosaurs. So I kind of said, that sounds like a good thing to do. So I turned my hobby into a career. And I am back to that. I'm almost retired. I'm like one more project and I'll be done. And I am back into my hobby. So I make radios and I write software, and you can look at my blog or look at my GitHub page. And so I've kind of full circle. So that's how I ended up being here. Matter of fact, my wife used to say, even if they didn't pay you, you would do this stuff.
I was going to say, is an engineer ever really retired? I don't know, but
you should see my workshop back there, or check out my GitHub page. No, there is,
I took a little different path than Saeed. I wasn't really sure exactly what I wanted to do when I came out of high school. I knew I liked science and math, so I came into RPI as undeclared engineering. But I wasn't sure exactly what discipline I wanted to go into. So I took a lot of the kind of entry level undergrad classes, and I looked, closely through all of the course descriptions and looked at kind of some of these seminars and like where you can go with different degrees. And that's how I really narrowed down to computer systems engineering and electrical engineering. And some of the key classes that really made me kind of steer this way was physics. I think that leaned me, I really like the physics 2 specifically, so that leaned me towards electrical engineering. And I really like doing a little bit of coding. I didn't want to go completely into computer science, but I thought electrical and specifically the, computer systems was a good melding kind of between those two topics that I enjoyed.
This is perfect that you're here, Alyssa, because you started out in the same pathway that lots of engineers that view this are going to be, thinking about. I'm undeclared, or I started out being a Mechie and it's not really for me, or I was a comp sci student. So really good stuff. Thank you.
I can really relate to that to Alyssa because I also got in as an undeclared engineer. I was just was looking for like what I didn't know what I was interested in until maybe like after the first semester, and then things kind of settled down after I took a couple Explorer classes that's like supposed to introduce to you different fields, and I was debating between ECSE and the Industrial System Engineering program. And then I decided on ECSE mainly because at that time it was also during the career fair season. So I kind of talked to the, I was a freshman then, so I went there totally just to learn like what it's like to go to a career fair, and from talking to the people are in that event, which is like a whole bunch of different employers, most of them are hiring ECSE students mostly. So then I'm like, okay, let me give this program a try, and because I know that I can still have time to switch if I don't enjoy it. So I decided to stay on ECSE, and then I guess Engineering Hub also helped out a lot. I think we're still the trial for the ARCH program at that time. So I needed a lot of help from the Engineering Hub, and they were very supportive of me in picking classes for my program in the midst of classes are continuously being changed throughout the season. So, but I guess it's the combination of classmates and the content that I am passionate about that kept me into pursuing to become an ACSC student.
Great. Thank you. Okay, James, you're up.
Yeah, so I followed probably a pretty similar path to Alyssa and Aiden there. I also came in as an undeclared engineer. I knew that I loved math and science. I knew that I loved problem solving and puzzles, but I didn't quite know how I wanted to put those things together into a plan of study or into a career. And so throughout the first semester, I made kind of a concerted effort to learn as much as I could about all of these different majors, right? I talked to different professors and different students at these industry hours and different events like that. I talked to people in the advising hub. I took a look at all of the course schedules and what classes you would be taking at different stages for the different majors. But probably the thing that I did that helped the most was talking to other students, right? Talking to other students that were also freshmen, talking to upperclassmen especially. I mean, if you, you'll find this out soon enough, there's nothing people at RPI like to do more than talk about their classes. And if you get someone talking about their classes, especially their elective classes that they have chosen at like the 4,000 level, once they're taking the things that they want to take, they will just talk about those for as long as you want and answer all of your questions. And that is the best way to figure out whether it's something you want to do or not. Because if they're talking about, you know, designing bridges or soil or those were the types of things like for civies or environmental engineers, I was sitting there like, this is interesting, but could I really see myself doing this? But then I loved computer and systems engineering because it had this huge blend where you got to work with hardware and electronics and the physics of it, but you also got to look into programming and the computer science side, and you kind of got to blend these two fields. And it seemed like a very unique major. And I could really see myself just talking with some of the upperclassmen that I knew at the time, taking the classes that they were taking, doing these projects that they were doing that all seemed like stuff that really excited me and that really made me want to dive into the field.
Great. Yeah, put a pin in that whole, project-based learning thing, because as you're at the end of your RPI bachelor's degree, lots of students would want to know about like that time, which kind of segues into our next question, which is all four of you walking us through what a typical day looks like. James, yours is going to look a little bit different, but you can speak to the student's experience and then transitioning into co-term as well. All right, Saeed, what does a typical day for you look like, or did it look like, or et cetera?
So let me ask you guys a question, because there is 4 top parts to my career. The first 22 years, I was a bench engineer. I designed circuits, analog, digital, mostly chips. I spent a lot of years chip designer. And then I spent the second half of my career was in corporate management. I ran divisions, did M&A integration. And then I spent since 2013, a couple of times running companies and a couple of times being private equity consultant. So I'd be glad, and they were nothing like each other. I will be glad to talk to you, and I think probably Alyssa is going to take you through a day in a working engineer's life, which I suspect there wasn't a lot of difference between what Alyssa does and what I did. So let me ask you, what do you want to hear?
It could be anything. And it's from all the different experiences, exactly like you just alluded to. It could look like, the project management side. It could look like actual engineering. When we heard from other types of engineers, they're literally standing in a field, which electrical engineers tend not to do as much, but it can run the gamut because everybody has so many different experiences.
I did my share of debugging T carriers on top of telephone poles upstate New York in winter.
Okay.
Yeah, but I'll let Alyssa talk about what a day in engineer's life is going to look like. And a lot of engineers transition into product management. So I'll talk a little bit about what I did as a product manager. So I was VP of product management for a product line. We grew the product from $400 million to 650 and launched a product that sold $10 million in the first 45 days and $100 million in the first year. So it's kind of one of the highlights of my resume. And I spent my days reviewing people's work. So you kind of have one-on-ones. Well, how are you doing? Spent a bunch of other time commissioning market research. Okay, you would send your product managers in the field. You talk to a bunch of customers. And if you got the same answer from 8 of them, that's a market. But if 10 different customers give you 10 different answers, that's not a market. You're not going to make a custom product from each company for each customer. I spent a lot of time on product launches. That's weekly meetings, reviewing exactly where you are with manufacturing, where are you with industrial design, where are you with software development, where are you with testing. How's your plastic supplier doing? Issues like, is the bottom and top of the product colors match? Any kind of regulatory compliance, because quite often the product you're making has some kind of regulatory compliance. So basically you spend a day a week and just making sure that and then how's sales training coming? Are the demo kits being put together for the sales guys? We were launching the product at World Cup in Munich. What are the marketing guys doing at World Cup in Munich? Anyway, so you kind of spend a day a week doing that. You spend another day a week reporting to senior management. Okay, how you guys doing? And then you get grilled on how are you doing with this and how are you doing with that, and whatever. And then there's vendor meetings. So we had a product line that we weren't going to make ourselves. One of our suppliers was making that in Taiwan. So you kind of spend time in Taiwan, and that's a long trip. Just see how they're doing, what the status of the project is. So that's what you do as a product manager. And when you're all done and the product's super successful, you go argue with your boss about your bonus and about your pay.
Sounds good. Thank you.
That is the story of me. It's like that's what you do as a product manager.
Right.
So from more of like the engineering day-to-day life, my role currently is I do a lot of digital circuit design for digital signal processing chains. So you can think of it implementing algorithms and circuits. So
Alexa,
my,
stop.
so
Not
my
you,
day looks
Alexa. I'm literally telling the Alexa in our office to stop. She just started playing music randomly, so apologies.
no worries. So my day looks pretty different depending on where in that design life cycle we are. So if it's early in the design life cycle, I'm doing a lot of kind of planning and design architecture. So this might be a lot of drawing block diagrams on boards and understanding the actual requirements for what we're trying to design to. When we're in the middle of that design process, I'm personally here writing VHDL, which is just kind of text that describes a circuit. So you can kind of think of it similar to coding, how you'd write code for computer science, but this is describing a circuit instead of an instruction set. So that's a lot of sitting in front of my computer, typing that up, simulating the code, and then maybe actually synthesizing it to build the circuit and make sure that it did that properly. And then when we're getting towards the end of the design life cycle, I'm doing a lot of integration and tests in the lab. So I'm collaborating a lot with other engineers at this point. You're sitting at a lab bench, maybe you're probing things or, looking at inputs and outputs of your circuits and making sure, things are doing what you're expecting them to do. Sometimes it ends just with some of that lab work, but a lot of times we'll end up going to a customer site and we'll get to do a demonstration there. So I have, stood out in the desert and done demonstrations there, been on large boats and helicopters and have done things there as well. So yeah, kind of a wide range of opportunities from, computer work to lab work to out in the field demonstration work.
I'm going to stop telling people that they won't go out in the field and stand in the desert because I guess the ACSE students and people that go into that field do as well. I stand corrected. Okay.
Wow. For me, it's a little bit different. When I joined this company 2022, most of us are working from home, so there's no really any in-person activity as much. We mostly use Slack to DM each other about project updates. Okay, maybe you make a channel, so we add all the stakeholders, all the team members who are involved with the project, and then we're gonna make like a Zoom, like a periodic schedule. So like around 9 a.m., you'd be like, okay, let's go in there and give updates for this project. And then like 12 p.m., we're gonna have to join another meeting to meet with a different group of people, and then we talk about another project. So most of my work are oriented by projects as opposed to there's PP programs. I think most of my work is related to, okay, are we able to test this feature for this project A? Are we able to test that feature on project B? And then also while working as a engineer in tests, we realized that there are generations of the products that we make every couple years. So not only we have to test features that are in the newest software, we also have to make sure there is backward compatibility with products that are in the older generation. For me, as a new grad joining that team, handling old software, it's easier than handling new software because the people who are in the company are known to the old product, but not known about the new product. So it's like I go to work, but I'm like learning new product feature from the people who actually build the product and then teach it to us to use it and run the tests. So a lot of like, oh, like I heard team A said that they completed this feature. Let's check with team A first. So a lot of learning, and then not too much about like designing circuits, but like on the up, like looking at it from end to end, like if a customer were to connect Wi-Fi around this time and watch YouTube for this many hours, are we able to build a test that's able to quantify if this is a good or bad or medium quality? So most of my tests and work are related to quality assurance, making sure that the item that we're selling in the market are working at the way they're intended to and marketed. And sometimes we have to deal with the people from legals because there are a lot of name change that can happen from time to time because they realize they don't like the name that they had initially. Then I will have to go back to all the documentation that we make as a test team to make sure that if someone in the real field, like real field, were to use this, they won't run into issues where like I thought you'd want us to do this, but then it doesn't have this button on this product. What do we do? So sometimes we have to talk to the satellite installer because they are the one rolling out the trucks to go to customers' home to install hardware, and we are in like our numbers on their phone for them to call us if there's any questions. So we have to be prepared to answer questions that we may not be familiar with. But most of the time, it's all about. Most of the time, it's less about this code broke, let's go fix it. Most of the time, it's more like if someone were to call us and be like, we need help, do we know the people that we needed to call to get help from? Those are my career currently, and then I'm working hopefully toward like a product manager sort of a position because realize that managing project there will be a time where like my manager will be asking me, what's your career trajectory in this company? And I wanted to be more hands-on with like products, and then now that I know more people in the company, I want to be more hands-on the product because I know who to ask for help when I have questions too.
Knowing your resources is huge. Okay, good.
Yeah.
James, so what's going on at RPI at this stage of your education?
Yeah, so quite frankly, my life probably doesn't look a whole lot different from anyone watching this day to day. If you're an RPI student, I go to my classes, lectures, exams, labs, and then in between that, it's filled with homework assignments, projects, extracurriculars, all of that fun stuff. The one thing I will make note of is as you progress through RPI, as you go through more, 4,000 level classes, they become a lot more project-based as opposed to some of those entry-level classes. You're not usually sitting in giant lecture halls all the time. You still are a little bit, but a lot of your classes you have a lot of time in them to work in groups. For instance, I'm taking a capstone class right now where we go in every day, and instead of having a big lecture, we all get together in a group and we work on our project. We do both design work type stuff as well as project management type stuff as a group in that class. And even aside from capstone, some of my other classes are very project based, where there might be a little bit of a lecture, just enough to kind of get you started, and then you start a project or a lab that might take 2 or 3 weeks, and you transition from out of kind of these busy work homework assignments that are just designed to be easy to grade and have a ton of people push everyone through Calc 1 and 2 real quickly. There's no more of that at this point. Everything I go to feels a little bit more substantive than that.
Nice. So for the next question, what's the favorite part of your current job or an internship that you've done? Starting with Saeed.
Given I have been around a bit, let me kind of maybe say a couple of general things. Probably throughout my career, the most favorite part of my job has been doing what nobody else wants to do. There was a time back in my design days, 3.5 micron CMOS doesn't run any faster than 2 megahertz. And okay, we need to design some chips that run at 4 megahertz. I'll do that. As a matter of fact, one of my patents is related how to run 3.5 micron CMOS at faster than it was intended to. And same thing in management. If there's a team that is can't get a new product out, In fact, I was doing a merger integration in Germany, and the guy who ran products calls me and he said, I got a team here that does not seem to be able to get a product out. They can't make any decisions. So I come back and say, okay, this is fun. I'll do that. So throughout my career, I've always volunteered to do stuff that nobody else wants to do. And that's best part. At least that's what I enjoyed the most.
I
All right,
think
Alyssa, I won't yell at Alexa or anything while you're talking.
my favorite part, I think, is the problem solving and having something kind of new to stimulate your brain every day. Along with that, kind of the variability of work. So depending on where in the design process you are, and a kind of a mix of hands-on work and computer work, I don't really get bored at work, which is a really good feeling. Get excited to go in every day and learn something.
Thank you. Aiden, that's
Yeah.
you.
Yeah. My favorite part, I guess, is waking up in the morning and then realizing that like we have automated script built to detect any system error that have happened in the last 24 hours. I know like why would you be happy? Like in the past, like when I joined the company, we did not have a tool like this, so everything was so manual. Like you have to go and like type in like a command, and then it turns out a whole bunch of logs, and you'll be just reading like pages of logs just to see, oh, what have happened in the last 24 hours. I guess like these days when I wake up and go to my computer and work, like we have tools that kind of summarize it for us. So like they would be like, oh, last 24 hours, we noticed that this happened, that happened, and this happened. I think it's because of X, Y, and Z. Like when our automation team was able, well, when we communicated to the automation team of like, oh, testing need this tool to like help us out with our workload, like communicating problem, like we give them some form of like ideas of how you can help us out, and then they actually implement some tools for us to try and then be able to make it official for us to use internally. It was amazing because like every time I'm like, oh, I wish you have a tool that do this so that it saves us man hour into checking like this log in server A, that log in server B, that log in server C. I can just have a bot that kind of pull all the information and then summarize it for us and pull it on like a, they call it a Plotly graph. So basically what I meant to say is like, if you need something, there's always a person who's willing to be like, okay, I hear your concern. Let's work this out and see who can help us out. I think that's what I enjoy about my job is that, other than like, you know, realizing that, oh, like this customer's internet is not working, let's figure out why. If you're not really solo in fixing this issue, there's like a channel. So like you can tag people, be like, oh, like, have you heard about this? Like, do you know how to solve this? And they are willing to be like helpful and also be willing to teach you like the tips and tricks and that they have to detect some of the error that can be consistently reoccurring in another customer setup. And then you are able to like, oh, like I can help someone else when they are seeing similar issues. And kind of gets me moving in the job because like I came in not knowing anything about Wi-Fi or anything. I was mostly like a they call it analog circuit designer classes type of a person. So walking from there to fixing internet, it was a big jump. But then it was like and people there were like very open-minded about like, oh, if you don't know this, let me know. We can just get a Zoom call real quick, and this can be done in like a 10 minutes. And then in 10 minutes, you learn more than probably 2 hours of Google search. So.
Great.
So do you want me to talk about internship here or favorite part of being an ECSE student? Which would you prefer, Jen?
Whatever makes sense to you. You could talk about the internship. You could talk about how much you love data structures while you're at RPI. Anything you want.
Yeah. So I guess I've done a couple of internships, but the most recent and most notable was with Western Digital. You'd probably have heard of them. They make hard drives for different computers, and I was working for them as an embedded software engineer. So basically, I was writing the code that gets stored on the drive itself to make sure that the drive can operate as expected, and it's able to put data on and pull data off in all the ways that it's supposed to. And that was a whole lot of fun. I'm gonna go back there again this summer, but probably my favorite part of that was just how much there is to learn, right? Kind of like what Aiden is saying. You go in college where there's this very clear structure of learning, right? You take this class and then you take this other class and they build on top of each other. But you go into a workspace, right? And it's a little bit different because they have just all of this institutional knowledge built up and you just kind of get tossed in the middle of it. And that's a little bit overwhelming at first, but there are tons of people there to kind of help guide you and show you where all the information is. And it feels like you can learn so much more by actually sitting down and doing something and playing with it yourself and testing it than you can, sitting and listening to someone lecture for 2 hours.
Absolutely. Great. Thank you. So let's see. I'm going to combine a couple questions because I want to be respectful of everybody's time as we go through. So speaking of electives, we touched on that a little bit. What electives that you took at RPI do you think make students going into electrical engineering, computer and systems engineering really marketable? And did anybody pursue a minor at RPI? Because that's connected to possible electives that might have happened. All right, Saeed, any electives that you found super meaningful during your time at RPI? Oh, did you mute yourself? No? Oh, you're muted.
Yeah.
Sorry.
I was muted. Yeah. I took enough math courses to get a degree in math, but at the time there was no money in being a math major, so I picked electrical engineering. But at the same time, a lot of my math courses helped me. Matter of fact, one of my patents, I talked about it earlier about how to run a chip fast. It's based on one of my courses in the math department, actually, in modern algebra. And I took corporate finance and micro and macroeconomics and money and banking. Money and banking just helped me be a better citizen, but corporate finance was definitely very helpful as I transitioned to general management, and it was a foundation for taking other courses like afterwards. So I would say, yeah, and I took things like baseball past and present, which turned me into a lifelong baseball fan. Anyways.
Okay. Very cool. And the Lally School of Management would be so pleased to hear you talk about the management classes there. We've been having conversations with them recently about co-terms. So nice.
Yeah. Matter of fact, I've been talking to the provost about how some of the humanities and social sciences can become more RPI-ish.
Very cool. Okay. See, we're all connected, all 5 schools. Love it.
Yeah.
Thank you. All right, Alyssa, what do you think?
So I did not do a minor. I did dual major though, so that took up quite a bit of my time. But some of I guess I'll speak about electrical electives first. I think like making sure you go into sort of a concentration and take a few courses at least that are related at the high, 4,000 level, especially that are project based, will really give you things to talk about at interviews, especially for your like first internship where you don't have any work experience. Project experience can really take place of that. But outside of kind of the ECSE department, I did take engineering management, which I think is still under the engineering engineering umbrella. But it talked a lot about cost and schedule and how to like run an engineering project, which has actually been pretty useful in my job now. I'm not like a product manager like Saeed, but still understanding how you're part of an engineering project really develops, I think has been helpful.
Very good. Yes, as you can and that dual major is still wildly popular at RPI. So that's good to hear.
So I actually did a minor, and I want to give a shout out to like School of Haas because I think I did my minor. I think at the time it was called massive communication, but it's just communication.
Yep.
But like I guess at that time before I was a senior, I really have limited work experience and everything else. I guess the School of Haas or writing department, they have courses where they ask you to research into a topic that you're interested in, which means it can be anything as long as it has to be technical paper, but like you can research into any field that you like, any topic that you like, that you have learned so far in your classes. So what that means, what that translates to is me like study circuit on that year, and then me taking the classes asks me, okay, go further from the one of the classes you took, pick a topic. So I think I did one of I think I did a class signal and system, and in there we talk about filters, literally filters, a whole bunch of filters. So I was like, I wish I can study a little bit more about the I guess it's a low pass filter, like what's current in that time, around 2021, what or 2020, what's new about this low pass filter. So then they taught me literally how to use RPI library resources to pull up scholar paper that is readable for someone who is a second year student to be able to gain more knowledge about a specific low pass filter type. And literally ever since I noticed that, I just keep taking writing classes because for each of the different writing classes, I get to pick to write a paper that I like. So around the second time when I took a different writing class, this time they asked me, okay, like for this project, you have to pick a different topic, not from your classes, but from everything we learned so far about news articles and that, and be able to write up an abstract about this. Like not abstract about UCSC, but abstract about paper we have written recently. So from there, I learned how to write abstract. And then from there, I was like, oh, like I didn't know how to write abstract at first in high school or anything. So like look at that. Learning how to write abstract is so important because I guess around my senior or junior time, they asked me to apply for a scholarship, like with like writing samples, but they don't want your whole writing sample. They just want an abstract of your writing sample. If I didn't take those writing classes, I would not know what I was doing at that time. So then I'm like, okay, let me just complete this another time. Let me just complete all the writing classes are in the RPI. They were very limited. There are not that many seats, not that many lecturers at that time. Also during COVID, so I guess the availability of the lecture and classes are spread throughout. So then, but anyway, I decided to just stay on and be like, okay, let me just try to write a couple more papers that I thought would be helpful. And then it did pay off because I did like a couple classes in DSP and above upper elective, but I don't have the prerequisite for those classes. I only was able to get in because I demonstrated that here's what I studied when I was a sophomore, and this is my writing sample. And they were like, oh, it seems like you actually done the effort to try to be in this class, so I can sign you in. So simple as that.
So words to the wise, how to get into a Haas class that's already full. That's actually very helpful though, because it happens.
Yeah.
So, James, what are your favorite electives?
Yeah, so I did do a minor in economics. I can't say I've used it that much in industry at all, but some of the classes have been very cool. I took applied game theory, which was a really fun course. And that one really kind of changes your perspective, how you see different interactions, and how you kind of make decisions. So I would definitely recommend looking into some of those economics courses. They can be pretty interesting. And in terms of actual other electives, I took a linear algebra as a math elective, and that has been immensely useful. I have used that in countless other ECSE classes, in various things I've done. Like if you really understand linear algebra well, that is like the foundation of everything. It's the foundation of robotics, it's the foundation of AI. Like you can do so much with linear algebra. In terms of the kind of ECSE in major electives, I mean, there is no right or wrong answer in terms of what to take. Like some of the ones I'm taking right now are microprocessor systems and computer hardware design, just because that's what I'm interested in. The thing is, I know some people try to game out what they're taking to appeal to employers or something, but at the end of the day, you just need to take what you're going to enjoy taking, because if you're not genuinely passionate about your whatever it is you're doing, an employer is going to see that, right? I mean, if you're sitting there and you're talking to them and you're not genuinely excited to be doing that work, one, you're not going to have a good time, and two, it's going to be obvious that you're not having a good time.
You mean linear
Um,
algebra is not a required course anymore?
It's not
it's
required.
not. It's not
That is
even
okay.
in the list of electives, but students will elect to take it, and that's always a huge conversation about the
Back in
linear
my
algebra.
days, first semester, sophomore year, you pass linear algebra or you don't go any further.
So they
Isn't
make
that
you
something?
do a course that is matrix algebra combined with multivariable calculus, but it is very brief and it is very surface level. They also offer a 4,000 level linear algebra course in the mathematics department, which dives a lot more deeply into the theory and is a lot more beneficial.
Yeah, no,
And
that's unfortunate. All right, I'll have to have a conversation with Mrs. Beal.
yeah,
I'll
it
be
does
up
come
there.
up though, and people are learning about it through word of mouth. The upperclassmen will tell like the freshmen. They're like, look at linear algebra, especially in terms of electrical engineering. But anyway,
By the
we
way,
digress.
in most AI system, a word is represented by a 300-dimensional real vector, and then you spend your time messing around with like 300-dimension real vectors. Like, how are you going to do that without linear algebra? Anyways, we'll have to have that conversation.
Great. Thank you all. That's very helpful. Oh, here's one of my favorite questions. What was a course that you struggled with at Rensselaer Polytechnic Institute, and how did you overcome the challenge of that class? Saeed, can you think of one?
Oh yeah, I have one on top of my
Oh,
list.
yeah.
I
have a
was
list.
doing very poorly in what it was known as electromagnetic theory back in those days, and I guess you call
Okay.
it fields and waves maybe today.
Okay.
So I went to see Professor Bradshaw, and I said, Professor Bradshaw, I can't be doing poorly in this course. I think it was my junior year. And he said, I tell you what, I will hold back on your exam, on your turning in your grade. And if you derive Snell's laws from Maxwell's equations, anybody who's into electromagnetic theory would know what that is. I will give you, I'll give you an A. So I spent my Christmas vacation figuring out how to derive Snell's laws, which tells you how light reflects or refracts in a lens or in a prism from Maxwell's equations, which are the basic equations of electromagnetic theory. And for that reason, that stuff is so burned in my brain. I've never forgotten the stuff. So that was my experience with a course that was doing badly, and the way I overcame it, I went to see the professor and says, throw me a challenge. I'll see if I can live up to it. And it was good. It was a lot of fun, painful, but good.
And you got the A.
I got the A, yes.
Nice. All right, Alyssa, what do you think?
Mine was probably a course called Strength of Materials. So I think it's out of the either mechanical or civil engineering department. And it was
Right.
something outside of the ECSE major. And this was still when I was trying to decide where I wanted to go. So I think this course was actually a good indicator of maybe where I shouldn't go. because the material was just less intuitive to me than a lot of the other courses I was taking in ECSE. And I just wasn't really motivated or, interested in the material as much. So it just made me, not want to pay attention as much and not put as much effort into the course. And that really showed in some of, just how much time I put into my assignments and stuff. So I think the first thing you have to say is it's a good indicator of where I should go. But in order to kind of fix the problem, I definitely took advantage of office hours and just talking to the TAs and all of that to get some extra support and really force myself to, spend time on the material I was less interested in.
Oh, good tips on the office hours and also knowing what you're not interested in and like changing your major, because it happens vice versa too. When students come to me and they're like, I hate all the circuit stuff. I'm like, maybe ECSE isn't the way to go. So yeah, good tips. Thank you. What do you think, Aiden?
I guess I did struggle with a class, but that class is called Designing Capstone, like the very, very last class before you graduate. I guess being an ECSE student and then being told, oh, you're going to be working on a project with people from different school, I think that was a little bit different. Shocking, not shocking, but we expected that, but then actually being able to crank out all the non-engineering detail with people not from your ECSE school, because you guys are definitely not taking the same kind of classes throughout the time. I guess some of the people that I worked with, they are very less about getting the details right, but more like getting the scope right. So like people in my team during in the capstone course have a different style of handling tasks. So when it comes time to, oh, we have a deadline coming in, they might be still are like, okay, don't worry, we're gonna get it done soon. But then I'm more of a like, let's get it done like a day before it's due, so that like we have time to get together and just edit the stuff, which is kind of like what we do in circuit lab. Like we have a plan first, and then we execute, and then we correct that, or figure out why something didn't go the way we wanted to, and then like something about that. But then other department might not be reacting the same way when there's a bigger project, because they want to have more time doing the experiment and then have less time analyzing it, and then just trying to complete it as soon as they can. Like a style of completing tasks was something a struggle for me, because like I'll be like knowing that our deadline is coming in like in 2 days, and then I'm not seeing anybody putting anything in when I'm in the team, and then I'm like, I didn't do anything the past 2 weeks. So something like that, and then just kind of learn to like be like kind of like we will have to take on leadership more, like, oh, then I have to kind of like be vocal about like asking people for updates. Whereas in the past, in most of my ECSE classes, like we get together after class end to try to get things done. But then during COVID, during capstone time, people kind of like in and out, because like they can be like, oh, I have like COVID testing around this time, I have to go. And like, oh, I don't live on campus, I have to get out of campus. And then, so that was a little bit hard to manage, but that was the point of the class anyway, is how you can manage a team, people on different schedule, but be able to carry out a product that's workable for the stakeholder. So having that, and then be able to like, oh, I can see why like the struggle that I had at RPI was applicable to my job, because people have different schedule. You just have to learn to work with their schedule and be able to make sure to get things done. Yeah.
Good points. Yeah, I never think about the impacts of how it is to like work with other people that are, not in the same areas, and that transcends into the field as well. Good points.
Yeah.
What do you think, James? Challenging classes?
So probably the most challenging class I've taken, and also one of the most fun classes I've taken actually, was last spring. I took a course called Introduction to Deep Learning. And essentially, this course started with the very beginning of deep learning neural networks, right? The most basic fundamentals of it. I mean, I think literally day one of class was going through the definition of vectors and tensors, like literally from first principles, from the basics. And it then proceeded over the course of a semester to go all the way through the history of AI, pretty much, all the way up to the types of GPT transformer architectures that we see in use state of the art today. So this course moved fast. Like each lecture was something completely different than the one before it. And it was tons of equations, tons of math going very, very quickly through all of this. And at the same time, in the background, we are doing projects where we're building these models ourselves, filtering out training data to train and test these models, which if you've never done that before is quite a process. It's not like other programming where you just hit a button and it works or it doesn't. Like it's a whole process to feed it data and to test it and to make sure it's actually giving you reasonable results. And so there were definitely times in that class where I felt like everything was going way over my head and I was like grasping just to understand the basics of what was happening, let alone implement it myself. But one of the things that was incredibly useful there was office hours, but then also just working with my peers. I had a number of people in that class who I didn't necessarily know before the class, but I definitely knew after the class, right? People who I would sit with and who we could discuss, oh, did you understand what he said when he was talking about this equation? Or, oh, did you understand how you implement this? And with 4 or 5 of us, you're able to kind of piece together some of these concepts in a way that it would take a lot longer to put together on your own.
Yeah, that cooperation piece is huge. Okay, nice. So you were able to make, those connections during that class because it was like, how am I going to get through this? That's a good
Absolutely.
strategy.
Well, and by the end of it, I felt like I learned more in that class than for sure every other class that semester combined. Like I took away so much from that, and I understand that material at a far deeper level than I understand most other classes because it kind of forced you to actually understand the fundamentals and the theory behind how every aspect of it worked.
That's amazing. Great. Because sometimes it doesn't go that way and you're like, I just survived this class, but you have deep understanding. So somehow, some way it worked out. Let's see. So it's almost 7 o'clock. So I'll kind of skip ahead and we'll talk about one last question, which is advanced degrees. Do you all recommend, or do none of you recommend a master's degree and professional engineering license? What do we think about those topics, Saeed?
I've actually, it all depends on where you want to go. I mean, if you're in the electric power industry, certainly a professional engineering license would be very helpful. I mean, in my line of work, which really most of it, 31 years of it was in Bell Labs, you really don't need one. But when I arrived at my senior year, given my interest in what I like to do, I just didn't know enough. So there was a bunch of courses that I hadn't taken yet. So it was obvious to me that I needed to stay another year and cover that stuff. So things like detection and estimation theory, more advanced statistics, because a lot of digital communication is done, statistically, and on and on. So I would say, depending on what you want to do and which field you're in, you got to make an assessment to see if it's valuable or not. But then I had this big debate with my dad about going to get a PhD. And he was pushing me to go get a PhD. He's a doctor, so he was, and he's passed away. But there's no kind of, in what I was interested, there was no value in that. So like I kind of didn't listen to my dad. So
It happens, but I want all the students to hear this because they're like, I'm going to get a PhD, I'm going to get a master's, but it has to come down to for what are your goals? So understood.
Yeah, and kind of it's not obvious other than unless you want to teach. Definitely, if you want to teach, you got to get a PhD. That's But if you want to go join a research organization, like I was never on the research side of Bell Labs, I was on the product side. But it depends kind of what motivates you. If you want to be a researcher, I wanted to be a product designer. I had no interest in research. Then and depending on exactly, and one of the things you heard here is like with Alyssa, she found it valuable to go get a master's degree. I found it valuable to get a master's degree because just the stuff I wanted to know, I didn't know at the time.
That makes sense. What do you think, Alyssa?
Yeah, so I graduated and got a job with just a bachelor's degree. So I guess want to point out that there are plenty of companies who will hire you with just a bachelor's degree to get your foot in the door. And a lot of companies will pay for additional education once you're part of the company. So my company did pay for my master's degree. So that's another kind of benefit to maybe holding off on a master's degree right away, especially if you're unsure of that, like, do I want to go into research or not? I guess the other advantage of getting the master's degree, a lot of companies will, give you a higher salary because of that higher education. And I think because I started working first, I got to, decide or see even more kind of like the concentration or the smaller part of the field that I wanted to study. So it gave me an idea of what I wanted to focus on in my master's degree that I maybe didn't have right when I graduated. But if you have that, right as you're finishing your bachelor's degree, that's maybe an opportunity to stay on for 6 months or a year and finish it off. So I think it's really dependent on what your goals are and what you're thinking you want to do with your rest of your career.
Great. Thank you. Aiden.
Yeah. So I gotta give a shout out to the hub again because around for this question, my advisor around sophomore year, I think it was Valerie. I think she was not around anymore. Valerie. At that time, I asked her the same question, like, do I need to pursue a graduate degree after bachelor? Is that what everyone do? And she told me this, like, you don't necessarily need to start as a master program student. The school is willing to accept you if you're going in just to take a graduate class for credit, not as a program participant, but just a non-degree graduate student, as long as you have a bachelor degree, as long as you have, and the reason that I got the reason for that is because if you don't know what concentration you want to go in as a graduate student on day one, you kind of like you will spend more time figuring out what do I want to do than actually focusing on the classes that you're taking for graduate classes. So why not just take a class, know the department a bit, assuming it's a different school. I don't know, it may not be RPI for your graduate education, who knows? Just to talk to the department first, figuring out what's current, what's current, and then decide, do I actually want to be in that program or another program? Because it depends on what you want to do. You don't necessarily need MSE in ECSE. It can simply as I just need a management degree plus a bachelor engineering degree. That might get you further along if that fits you. And then some company also if you were to able to get a job with a bachelor degree, the benefit there is definitely the networking is going to help you. You can expand your network a bit. Like you can talk to people who are at the manager level. You're like, okay, like if I were to want to work towards a career path towards where you are now, what do I need to do? Do I actually need a master degree in engineering, or do you need someone actually with a skill of management project? Because managing project, because those are two separate things. Like having a skill to manage project, it's beneficial for the business. Having the skill of learning more about a specific topic in technical area, that's what engineering do. If you allow yourself to have more time to figure out what's out there now and then what you actually really like to do, then it's easier to apply with a personal statement that's more applicable to your career path. Because when you're applying for any graduate program, you need to provide personal statement. And personal statement is supposed to help you out with what you want to do once you are graduating from that department. So it should help you out if you talk to more people. It should help you out if you give yourself some time to like explore a bit. And then yeah. And sometimes I did graduate degree because I want a career shift. As simple as that. And I was able to do it. I didn't do it because I need a different higher pay. I just want a career shift, and I did.
That makes sense too.
Yeah, it was kind of like it was. I would recommend graduate degree, but only if you are really like I'm gonna get this done in X years, and that there should be like a 3 to 5 year plan ahead of you. But like, if I did this, then I can do X, Y, and Z. And it shouldn't be, I'm going to deal with it after I graduate from graduate degree. That would be a little bit like, you need more plan than that.
That makes sense too. All right, James, how do you feel as you're about to jump into the master's degree?
Yeah, so I think I was probably in a similar boat to Saeed in this regard, where I am starting my master's largely because I want the opportunity to explore more different classes and really try to figure out what I want to do, what kind of a niche I want to carve for myself, right? I've actually already started coterm now. I would like to highlight kind of the value of coterm at RPI, because it really is a fantastic opportunity for a variety of situations, right? Because right now I had 11 credits this semester left to finish up my bachelor's degree, which isn't even a full semester technically. So I could have just, filled it with stuff, been done a semester early, but then do what? I quite honestly did not know. So I was looking last spring and I figured, okay, I can apply to coterm and I can start my master's degree right now. So right now I'm taking 2 master's classes on top of finishing up my undergrad, which is fantastic because that means that the next 2 semesters I'm going to have more time to devote to research, more time to devote to other things without trying to take a million classes at the same time. Also, I was looking at my plan, right, for which classes I would be taking. And I realized that for my undergrad degree, after, 3.5 years at this school, I would have taken a grand total of 2 elective courses, maybe 3 elective courses in the ECSE department out of the dozens that they offer. And I was looking at that and I'm like, am I really getting the full value out of this school if I'm just kind of leaving all of that kind of sitting there? So I wanted to have the opportunity to take a lot more classes, a lot more varied classes, as well as the opportunity to dip my toe in the water in terms of research. I'll be starting master's project stuff for credit as part of that program next semester, and that'll continue through the end. And so that really lets me kind of have the widest possible breadth in terms of knowledge and experience that I'm getting. And also with coterm, they let you keep any financial aid, any scholarships you got going into undergrad, which is awesome. And then it also lets you have this very seamless transition where you can take classes from undergrad and master's at the same time concurrently, which just really helps in terms of scheduling.
Looks like you're surviving. You're sitting up straight and taking your master's classes at the same time as your undergrad. So I think, it's doable, it seems.
Yeah, not dead yet.
Still surviving.
By the
All
way,
right,
James just said something. James
Oh, yeah.
just said something we should really make sure everybody knows, that it's a
Okay.
lot easier to overload undergraduate and then carry 9 or 12 credits in towards graduate year, and then have very few classes so you can spend your time on your master's thesis or project. That's what I did. I carried 12 credits. That makes sure you finish in 1 year as opposed to drag it out longer than you need
Right.
to.
That's a really good point. Yeah. Research, get that in there too. You can just pack it all in.
Yeah, because doing your thesis or project could be very time consuming. And if you're trying to do
Right.
a bunch of courses at the same time, it's hard.
For sure. Okay, that's a very good point. Exciting. All right, since it is 7:11, we will leave it there. I thank everybody for coming today. I am going to stop the recording, but again, we will put this recording on our Instagram and our social media, and of course, the School of Engineering website. Thank you to all of you. I apologize that I've been on a cell phone for the past hour, but I appreciate you being flexible with me. And after we get off here, I'll go throw my laptop away or at least submit an IT ticket. Thank you to Alyssa and to Saeed and to Aiden and to James. You guys enjoy your night. Happy holidays. I can't believe I'm saying that already. And I will definitely email you guys all soon with some follow-up info. Thanks for everything, everyone. Thank you, Kelly. And it doesn't look like we had any questions, so we can kind of like tie up that bow as well. Have a great night, everybody. Thanks again.